Alright, welcome back. So let's have a look today at trigonometry of term 3. So the questions I'm using all comes from past papers ranging between 2016 and 2020, which you can get for free on the internet, or as well as different applications. If you go into your Google Play Store, search grade 10 past papers, there you will also get some of these papers. Alright, so let's get started. So the first thing I want to look at today is your trig graphs. Okay, so in question 6 they say, consider the function y equals to 2 tan x. Alright, so that is the function we are going to use. Then at question 6.1.1 they say, make a neat sketch of y equals to 2 tan x, for 0 to 360 degrees. Okay, so this means that your graph has to start at 0 degrees and it has to end at 360 degrees. Right, because x is in between 0 and 360. And then they say on the axis provided, clearly indicate on your sketch the intercepts as well as the asymptotes. Alright, so this is where you'll get 1 or 2 or 3 marks. So it's very, very important to indicate it. Alright, so when you are asked to sketch a graph, you know that you can use your calculator. So let's go and do that. Alright, yeah, I quickly draw a simple diagram. So along my table, so you can pause the video, quickly draw your own table. Alright, but they said we have to start at 0 degrees and we have to end at 360 degrees. So you can choose in what you want to count. However, when I'm working with tan, I prefer to work with 45 degrees, but you can work with 30 degrees, 90 degrees, it is your choice. Obviously, the smaller you make your range or your intervals, so now I'm counting 45, so the smaller you make your step or your interval, the more accurate your sketch will be and the less chances you have of making a mistake. Alright, so they taught us, I just quickly want to go back, the function is y equals to 2 tan x. Alright, so you're going to go into your calculator and then at the top button there will be an option that says mode. And if you go onto mode, you're going to scroll through your modes. If you have an older calculator, you only have 3. If you have a newer calculator, you have about 8 options. But on most calculators, option number 3 is your table option. And when you press number 3, it will automatically give you the screen f of x equals, and then you have to fill it in. Alright, so f of x is just a symbol we use on a calculator for y. So you're just going to put in, after f of x, you're going to say it is 2 tan x. Then your calculator is either going to give you a g of x if you press the equal sign, or it's automatically going to go to start. If it gives you g of x, just press the equal sign again so that you can skip it. And then the next question it's supposed to ask you is where would you like to start? Now obviously we would like to start at 0 degrees. Then it asks you where do you want to end? We want to end at 360 degrees. And then the last question asks you is what do you want your step to be? So that is your intervals, and what are we counting? We are counting in 45s, so my step will be 45 degrees. Then it's supposed to give you a table with an x column and an f of x column. So the x column, your left-hand side column, is the same values I put here, 0, 45, 90, 135, 180, and your right-hand side is what your y value will be. Alright, so please pause the video, do it on your calculator before you continue so that you can make sure you know what to do. Okay, so when I got 0 degrees, I saw that my y value will be 0. When I have 45 degrees, my y value is 1. At 90 degrees, something interesting happens. Alright, your calculator there will give you a math error. So whenever you have a math error, you know, oh, this is going to be my asymptote. Oh wait, sorry, I made a mistake here. At 45 degrees, it's not 1, it is 2. Alright, so it's going to be 0, 2, at 90 degrees, math error, meaning there's an asymptote. Then at 135 degrees, you have -2. At 180 degrees, you have 0 again. 225, you have 2. 270, I also have a math error, which once again means I have an asymptote here. And then at 315, I have -2. And at 360, I have 0. So having these points, you can now go and sketch your table, your graph. So usually they do give you a graph paper. If not, you just go and draw your own. Alright, so there I drew mine. Okay, so let's once again, we counted in 45, so let's put it into 45. So obviously in your x-axis is where your degrees will lie. So there's 0 degrees, here we'll have 45 degrees, 90, 135, 180, 225 degrees, 270 degrees, 315, and then lastly 360. And then your y-axis is where your y values will be. So I have 1, I have 2, and then I go back, I have -1, and I have -2. Alright, the first thing you want to plot is your asymptotes. So we have an asymptote at 90 degrees. So I'm going to make a simple line here. Okay, I don't have a ruler unfortunately, so my line is a bit skew. And then at 270 I also had an asymptote. So once again here I'm putting my stipple line. Just make sure whenever you have an asymptote, it means your graph is broken. So if your graph was going up before the asymptote, after the asymptote it has to go down again. Alright, if it was going down and now your asymptote comes, it breaks your graph, now your graph will start going up again. Alright, so we see at 0 degrees I have 0, and at 45 degrees I have 2. So can you see this tendency of my graph now will be to go up? Okay, so we're going to connect my two dots and it has to go up towards my asymptote. Remember, it can never cross your asymptotes. Okay, then at 135 degrees I had -2. 180 I had 0. So here I can obviously see, but wait, my graph is going down. So it's going to go down and curve downwards and towards my asymptote. Then at 225 it is at 2 again. So now it goes up and it's curving towards my asymptote again. Wait, that's a very ugly one. Okay, so I need to be able to see that it's going closer to your asymptote as well as going up. And then at 315 I had -2 again, and at 360 I had 0. So it means here it is curving downwards again. Right, make sure your graph has a nice bend shape. Alright, I'm drawing on a tablet, so for me it's a bit difficult, but make sure it doesn't look like a straight line, because a tan graph is not a straight line, it is a curved graph. Alright, so how will you get marks? So the first thing will be, did you have your asymptotes? Yes, you did. Did you have a correct x-intercept, so it's 0, 180 and 360? Yes, you did. And then lastly, the shape of your graph, is it going in the correct direction, and is it curving correctly? So is it going towards your asymptote and also going up or down? Alright, so there we did question 6.1.1. Now let's have a look at question 6.1.2. They say if a graph of y equals to 2 tan x is reflected about the x-axis, write down the new equation. So remember, when something is reflected about the x-axis, it means your y sign changes. Alright, so if your y sign changes, it means if my graph was going up, it's now going down. And if my graph was going down, it is now going up. Alright, so originally I had y equals to 2 tan x. So now if it's going to reflect, it means my entire thing, all of my signs have to change to the opposite side. So I had a positive 2 tan x. So now if it is reflecting, it's going to become y equals to negative 2 tan x. Alright, this is a very important question. They love asking it in a test. So make sure when you have a reflection about your x-axis, it means your y sign has to change, which in effect means that your entire function, everything you had on the right hand side, all of those signs have to change. So we had a positive 2 tan x, now we have a negative 2 tan x. Alright, if we quickly look here at question 6.2, they tell us the diagram below shows the graph g of x equals to a sine of x. Alright, sine, we can see it because it's going up and down like a wave. Once again, it's also drawn from 0 to 360. So in question 1, 2.1, we're asking determine the value of a. Alright, so a is there in front of my sine. So that is basically your amplitude, and then as well as is it a positive or a negative graph. Now, the easiest thing always to do is just draw your original sine, cos or tan graph. So my original sine graph starts at 0, at 90 degrees it goes to 1, at 180 degrees it goes back to 0, at 270 it is -1, and at 360 it is 0 again. So my original graph will run here. If you don't know it out of your head, you can once again use your calculator. Like we did in the previous example, use your table mode and just get the values. Alright, so to determine what changed with A, we always look at our tummy area, so where it goes round. So originally it was at 1, alright, so my amplitude was 1. Now it is from 0 to 4. So now my amplitude is no longer 1, but rather it is 4. Okay, if we look on this side, going down, it goes from 0 to -4, which means my amplitude is still 4. It's going in the correct direction. As a normal sine graph, it's going up and then down, so it means my value of A will also be positive. If it was going down and then up, then it would have been a negative A value. Alright, so therefore my A value will be 4. Okay, A is your amplitude as well as whether your sine graph is positive or negative. At question 6.2.2, they say, if a graph of G is translated 2 units upwards, okay, write down the new graph of H. Right, so originally now I have g of x equals to 4 sine x. And remember, if it moves 2 units up, it means I have to add a 2 at the end. So h of x will now just be 4 sine x plus 2. Alright, that is all for this video. So make sure you know how to draw a tan graph using your calculator, as well as your basic functions, which is sine x, cos x, and tan x. And then also what does the different numbers, your a and your q, mean.